Hey everyone. So in this video, we're going to be looking at projectiles again, but instead of it being launched horizontally from some raised up surface, we're going to be looking at a object that is launched at an angle up into the air from level ground. Okay, so it's going to land in the same spot that it is launched from. Okay, so without much further ado, let's share screens. Okay, there we go. So we're all set. So once again, I'm going to set up my problem here. Okay, it looks like I'm good there. Here we have the ground. Now I don't have a super steady hand, so just pretend that's nice and horizontal. Okay, I'm going to launch something, whether I could, I could kick a ball, I could throw a ball, I could whatever. And it's going to follow this path, right? Notice that it is parabolic. Right? And the initial velocity is up that way somewhere, and this is at some angle. Okay. So how do we approach this? Well, first, let's set up a sample problem and see what we can do. So let's say the VI, which is this kind of diagonal, is 10 meters per second. Okay? I'm going to make that look closer to a 10, not a star. Let me rewrite that. VI equals 10 meters per second. Excellent. Okay, let's give a theta of, let's say 20 degrees. Okay, so this thing was launched at an angle of 20 degrees with an initial velocity of 10 meters per second. Cool. And let's say we're looking for, in this case, the time of flight. So I want to know the whole time, the time that it took from beginning to the end. All right, so how are we going to do this? Well, once again, we need to make an XY chart. Okay, we've got values that are just horizontal. We've got values that are just vertical, and we cannot mix them in an equation. Okay, so let's set up our XY chart. Okay. So let's think through and see which values do we know are just horizontal and then which ones are just vertical. Okay. Well, to start, we know that the horizontal acceleration is 0 meters per second squared. Okay. We don't know any information about the displacement. We don't know any information about the time yet, right? Because that's what we're ended up looking for. But what about initial velocity? Well, the initial velocity is kind of pointing like this, right? This is 10 meters per second, and it's at an angle of 20 degrees. Well, notice that's not all horizontal, nor is it all vertical. So if you think back to vectors, what do we have to do? We have to find the components. So how do you find the horizontal or the x component of this vector? Well, it's going to be your initial velocity times the cosine of the angle. Okay, so let's plug this in. Okay, so that's going to be 10 meters per second times the cosine of 20 degrees. Put this in your calculator, and I don't have that memorized, so let's do it right now. 10 times the cosine of 20 gives us 9.3, it rounds up to 9.4. Okay. And on my calculator, it says 9.3969. It just rounds up to 9.4 meters per second. So because of the fact that we found this horizontal component of the initial velocity, we can put this here. Vi sub x equals 9.4 meters per second. Excellent. And that is currently all we know about the horizontal direction. Okay. All right, now how about the y? Well, acceleration is due to gravity, 9.81 meters per second squared. But here's the key thing, and it's a major difference between this type of projectile and the one where it's launched horizontally from some raised surface, is the initial velocity points kind of up, right? It's got an upward kind of piece to it. Whereas gravity acts down. And if you remember from vertical motion problems, in order to handle that change in direction or that difference in direction is to make it negative, right? So we're going to need to make this value negative, right? Because the projectile kind of points up and gravity points down, we need to show that difference in direction. And to do that, we make one of these negative. And I chose down to be negative. Okay, great. What else? Well, we don't know anything about the height of anything, but we do know one thing. Okay, here and here is the same height, which means the overall displacement for this projectile is 0 meters. Okay. We also know something right here. Right? Remember apogee. I'm going to do V sub A, meaning apogee. Okay. Vertically, apogee has a speed of 0 meters per second. Horizontally, apogee is not 0 meters per second, right? Because it can't slow down if the acceleration is 0. But vertically, yes, the speed is 0. And we can sometimes use that to our advantage. Now, how about even an initial velocity? Well, just like with the horizontal, we need to find a component. So let's set that up. VIY equals, and again, if you remember from vectors, to find the vertical or the y component, we do VI times the sine of 30 or theta. I'll just keep this the equation version for now. Okay, now plug in our values. 10 meters per second. I almost even wrote in the wrong angle. Unbelievable. Sine of 20 degrees. Okay, plug this in. Let's see. Again, I don't have this memorized, so let's do it. Okay, we get 3.42 meters per second. Right, it's 3.4202, blah, 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 a whole bunch of other stuff. Okay, awesome. 3.42 meters per second. All right. Excellent. Now, even believe it or not, since this projectile was launched and landed at the same height, we know that the final vertical velocity will just be the negative of that initial velocity. Right? Because it took the same amount of time to get from here to here as it did from here to here. Right? And if it took the same amount of time to slow down as it did to then speed up, since acceleration is constant, well, that means the final speed will be the same as the initial speed. Great. So let's find our time. Okay. Well, we can do this in 2 ways. Okay. I'll see if I can do this. I may need to end up erasing this, but we'll see. Okay. As you can see, our vertical column is much fuller than our horizontal. Okay, so we're going to use our vertical values to solve for this time. Okay, now, based on what I'm seeing here, I think it would be easiest to use this equation to find our time. Okay. So let's use this. Right? We'll start with our final velocity, which we say down here is negative 3.42 meters per second equals positive 3.42 meters per second plus negative 9.81 meters per second squared times time. Okay. Do some math. So we subtract 3.42 from both sides. We get negative 6.84 divided by 9.81. And let's see. We get a time of 0.7. It rounds up to 0.7 seconds. Okay. Again, on the calculator, it says 0.697. It just rounds up to 0.7. Awesome. Awesome. Okay. Now, that's one way to do it. Here's another way. It actually involves the same equation. Okay. What if I made my apogee my final? Right? I know apogee is halfway. So what if I found time to apogee and then multiplied by 2. Would that give us the same answer? Well, let's find out. Okay? If you're going to do that method, you've got to use your apogee speed for your final speed. So that'll be 0 meters per second equals 3.42 meters per second plus negative 9.81 meters per second squared times time. Okay. Solve-a-roo, and you get time equals, let's see, 3.42, 9.81. Okay. Get about 0.35-ish seconds. Oops, let me fix that. Seconds. Okay. Looks different, but remember, finding to apogee is only halfway, so we got to multiply this whole thing by 2, which, ta-da, equals 0.7 seconds. Oops, hooray, hooray, hooray. We did it. Okay, and this is the set of steps that you have to take to find anything, right? If I were to find range, right now I can use this time to find range. If I wanted time to apogee, oh look, 0.35 seconds. If I wanted the maximum height, right, that would be another equation, but height is vertical, so you would just use your y stuff. You wouldn't even necessarily need to find time to find the maximum height because you have enough values in other places. You just got to make sure that you use values that are appropriate for that point in time. Okay. So for example, if you're trying to find max height, you wouldn't want to use this, right? Because that's at the end. And you wouldn't want to use this, again, because that's at the end, right? So you'd want to use stuff that works for the apogee, the max height. That's your acceleration, your velocity at apogee, and your initial velocity. You would use these two circled values for anything here at the end. Okay. So you just got to go through, see which values you have, look and make sure that you're looking at the appropriate spot and using the values for those appropriate spots. You know, is it apogee? Great. Use apogee values. Is it at the end? Great. Use values from the end. Okay. And that is pretty much it. Okay. I hope that was helpful, and I'll see you next time. Bye.